Dear students, our topic is sets. First of all, you have to know what is actually set. So in this chapter you will learn the definition of sets and different types of sets and how to represent these sets. Before starting this set, you should know about what is the object. Okay, in mathematics, everything in this universe, it may be living or non-living, these are all the objects. Okay, now in the definition you will find this one: a set is a collection of well-defined distinct objects. So three terms are actually used. One is the collection, next is well-defined, and next distinct objects. So as you know, this object may be termed in set theory in two ways. One is a member of the set, okay, member of the set, and another one is the element of the set, okay, element. Okay, now what is a collection? Collection is nothing but a gathering of some objects or the members or the elements. Okay, and what are actually well defined? A given collection of objects is said to be well defined if we can definitely say that a particular element is in the given set or not. And a set is always defined as the capital letters, as for example A, B, C, D, or X, Y, Z, whatever you like, you can apply. Okay, few are special characters and special alphabets by which we can denote the special type of sets. In this section you will find what is actually set and what is the representation of set. The collection of even numbers less than 10 is the set containing the numbers 2, 4, 6, 8. Suppose we consider it as E, and this E contains these four elements 2, 4, 6 and 8. Okay, E is the notation in which by which we can represent the set, and the elements will be taken in the second bracket. 2, 4, 6, 8 are the even numbers which are less than 10. Okay, next is students in a class. Suppose the students are Dilip, Robin and Kiran. So you can write the set name as A's, and the respective students are respectively Dilip, second one is Robin, and third one is Kiran. And you should consider these elements, that is the members of the set, will be separated by commas. Okay, next, states of matter. Suppose this is written as S, and in the second bracket you will write the elements. Say first one is solid, next is liquid, and third one is gas, and fourth one is plasma. Okay, these are the presentation how we can represent the set. Next, how to specify a set. Okay, this is the form. There are two types of forms. One is roster form and another one is set builder form. This roster form sometimes denoted by your tabular form also. Okay, tabular form. And the second form is also sometimes denoted by the property form. Okay, property form. So in roster form, a set can be written as in the second bracket, say 2, 4, 6, 8. The earlier example is taken, and all the elements will be visible in this set notation. Okay, but if you want to write the in set builder form, how to write? You have to write in set property form. Suppose I want to write few elements, say B, which contains the elements 1, 2, 3, 4, 5. Okay, now if you want to write it in set builder form, then you have to write it in this way: B is equal to X. X is an element of B. This is the representative of the set B, such that X belongs to the set of natural number and X is less than 6. Okay, X is less than 6. X such that X belongs to N and X is less than 6. You may write this one in this way also: B is equal to X such that X belongs to the set of natural number and X is less than or equal to 5. As you know, less than 5 means the numbers which are lesser than 5, and the number will be natural numbers, and you know the first natural number is 1, so there is a boundary in the lowest part, that is the least natural number will be 1. So 1, 2, 3, 4, 5, since there is a equality sign also used, X is equal to 5, so in this case you can consider the 5 also, the natural number 5 also. So in the roster form or the tabular form, the set B is written in this way, but in set builder form or the property form, the set B is written in this way. Next is the empty set. What is empty set? The definition, the term says, the definition actually, a set containing no element at all is called the empty set, or the null set, or the void set. Sometimes it is denoted by phi, or sometimes only the second bracket. As you know, in second bracket, if you do not put any value, then it will be an empty set. Sometimes we write it in this way, say the set A is equal to phi. That means we understand the set is empty. Sometimes we can write the set A as only the second bracket, which is containing no element. Okay, this element, number of elements in the set A is 0, and it is termed as the cardinality of the set A. Okay, and A is equal to 0. Next is one example. X has that x belongs to n, that is the set of natural number, and 2 less than x less than 3. Now if you draw the real line, suppose 2 elements are taken, 2 and 3, and actually this is the line for natural number. Okay, natural number, because x belongs to n, isn't it? So two numbers 2 and 3 are taken on this real natural number, line of natural number. So in between 2 and 3 you will not get any value, any number, because 2 and 3 are the consecutive natural numbers. So in this case you are getting nothing in the set. This is empty. Okay, next example you can consider, say x is equal to x square plus 9. X is an even integer. Okay, so x square is equal to 9 means x is equal to your plus or minus 3, either plus 3 or minus 3. None of them is even integer. So in this case the set is also a null set, isn't it? Because plus 3 is not an even number, minus 3 is not an even number, even integer. So for this the set is again empty. Okay, next, singleton set. Singleton set means a set which is containing only one element is known as a singleton set. As for example, x such that x belongs to z and x plus 9 is equal to 0. In this case, if you calculate, you will find this is x is equal to minus 9. So the element of the set is minus 9, which is a singleton set, because there is only one element. If you want to get, suppose this is the set A, and A is equal to x such that x belongs to z and x plus 9 is equal to 0, and it is containing minus 9, and you know the cardinality of the set A is equal to only 1, because the set contains only one element. The element is minus 9. Okay, another example, say set B, which is containing the element 0, is a singleton set whose only element is 0, isn't it? And the cardinal number of this set B is also 1. This is very important. The cardinal number of B is 1. Don't try to write the cardinal number of this set B is 0, because you may think that the element is 0. 0 has no value, but in this case 0 is a member of the set, so the cardinal number of the set B is 1. Okay, now is finite and infinite sets. An empty set or a non-empty set, which the process of counting of elements surely comes to an end, is called a finite set. A set which is not finite, then it will be termed as an infinite set. That means you may find a set, say A, which is containing all the vowels of the alphabets, English alphabet, A, E, I, O, U. So if you start counting, you may find the first element is A, second element B, third element I. In this way the fifth element is U. So your counting will be ended at some moment. So this type of set is termed as a finite set. Otherwise it will be an infinite set. As for example, set of real numbers, you know, a set of real numbers you can count, but after some moment you will leave it, because it is not ended in any moment. Okay, so for this is an infinite set. The example A is equal to 5, 10, 15, 20, 25, 30. This is a finite set because there are finite number of elements. What is the cardinal of the set A? Cardinal of the set A is 1, 2, 3, 4, 5, 6 elements there. So the cardinal number is 6. In the finite set you will get the cardinal number, that is the cardinality of the set. But in infinite set you will not get this one. Set of all natural numbers, infinite set, and you know this is denoted by n. 1 2 3 4 5 6 and so on. This is going to positive infinity. So set of all natural numbers is a infinite set. In this way, set of natural whole numbers, set of real numbers, set of rational numbers, all are the infinite sets. Often used sets, these are the notation. The n is the set of all natural numbers, and you see 1 2 3 4 5, this is an infinite set. And w is the set of all whole numbers. It is started from 0. The least whole number is 0, and this is the basic difference between natural number and the whole number, that the natural number starts with 1 and going to positive infinity, and w, that is set of whole number, is started with 0, and it is also going to infinity, positive infinity. So both are infinite set, but there is a difference. And z, that is the set of all integers. Here it is also an infinite set. Some are positive integer, some are negative integer, including 0. 0 is neither positive or negative, so this is also an infinite set. And p, that is the set of all prime numbers, and you know the first prime number is 2, and continuously you continue these 1 2 3 5 7 11 13 17 and so on. So this is a set of all prime numbers. Okay, this is also infinite. Q, the set of all rational numbers, and in class 9th and 10th standard you got this one, a number which is represented in the form of p by q, where p and q are integers. Q is not is equal to 0 are the rational number. So if you get this type of numbers, then obviously these are the set of rational numbers. You know, in between two integers, suppose 2 and 3, there are infinite number of rational numbers. So since in between two consecutive numbers there are infinite rational numbers, so if you consider the real line, so in the real line you will get infinite number of huge numbers of rational numbers. So this is also a infinite set. And the real set of real number, this is the father of all these sets. Okay, father of all these sets. So R is the set of all real numbers, and you know the real line, this is from negative infinity to positive infinity. That is 0 1 2 3 and so on. On the left side, -1 -2 -3 and so on. Not only these integers are on the real line, but also some other rational, irrational numbers will be on these real numbers. So a set of real numbers is also infinite. Okay, next is the universal set. This is very important. What is actually universal set? The universal set is denoted by U, capital U. Okay, this is the representation form, and the set of all elements from which given any set is drawn is known as the universal set. As for example, you consider the example set 0 1 2. Okay, only 0 1 2 is taken, 3 elements are taken. So you can understand what could be U for the, in this case you may take U as the whole number, set of whole numbers. Okay, you may be the set of whole numbers starting from 0 1 2 3 4 and so on, because the total set 0 1 2 0 1 2, this is a subset of U. So in this case, in this context, you can say that U may be the whole number, set of whole numbers. Okay, or the integers, because integers contains the positive integers and negative integers including 0, and 0 1 2 is one of them. Is a set which is the subset of this set of integers or the real numbers also. So context says what type of universal set you will consider. For the set -2 0.4 and 2, so actually suppose this is set B and containing the elements -2 0.4 means 4 by 10, that is 2 by 5, and another one is 2. So you find some numbers are negative integer, some are positive integer. There is also a proper fraction. So in this case, what will be the universal set? You may take the universal set as real number. Okay, if you take the universal set as real number, then this set B will be a subset of this real number. So in this case, you consider a real number as the universal set. Okay. Next is Venn diagram. When you study the set theory, and this is sometimes difficult to understand algebraically, so the graphical representation is very important. In this way, you can understand the set very easily. Suppose there is the universal set, and the universal set is termed as a square form, and the other sets which are subset of this universal set is denoted by the circle. Okay, suppose we take the example, S is the set which is containing the vowels of the English alphabet A, E, I, O, U, and universal set U is the set which is containing all the English alphabets. In this case, obviously your S is subset of the universal set U. Okay, so the box represents the universal set. Here this is the box, and the circle represents the sets. Okay, there may be many sets. One set is here, this is the set of all consonants. Okay, this is also a set. This set consonant is the subset of the universal set. Suppose this is capital C, so this capital C is also a subset of the universal set U. Okay, next is set cardinality. As I earlier said, what is actually the cardinal number of a set? The cardinality of a set is the number of elements in a set. Okay, so consider the notation NA. A is the set, and N means the cardinal number of this set A. Okay, you have to consider this example. If R is equal to the set 10, 20, 30, 40, 50. So first of all you count, this is number 1, number 2, third element, fourth element, fifth element. So the cardinal number of the set R is equal to 5. Okay, next another example, n phi is equal to 0. Cardinal number of phi, you know, phi is actually a null set, and the cardinal number of this null set is equal to obviously 0, because there is no element. No element means there is 0 element. For this, the cardinal number of the phi, that is the null set, is equal to 0. A set which with one element is called a singleton set. Okay, this is another one. Suppose the set is A, which is containing only 5. So what is the cardinal number of the set A? Set A is equal to 1, because 5 is the only element of the set A. For this is a singleton set, and the singleton set has the cardinality as 1. Next is power set. This is very important. Actually, the power set of S, this is written by P S. S is the set, and P is the notation for power set. Okay, P S is the set of all the subsets of S. Okay, as for example, you take this one, S is equal to 0 and 1. S is a set which is containing two elements, 0 and 1. What is the cardinal number of this set S? This is equal to 2. And what are the all possible subsets of S? So you can write in this way. There are 5. Phi is the subset of all sets. Okay, and you can take 0 as one of the set. 1, taking the one element 1, you may make another set, and 0, 1, taking all the elements at a time, this may be another set. So how many sets are actually subsets are created? 5, 0, 1, and 0, 1. So what will be the power set of S? The power set of S will be this 5, 0, 1, and 0, 1. So this is the power set. And what is the cardinal number of this power set? You just follow, there are 4 elements, so the cardinal number of power set is 4. There is also a rule to find the number of elements of the power set, that is the cardinality of the power set. As you know, the rule is 2 to the power n. Okay, 2 to the power n. And since in this set S there are 2 elements, so it will be actually 2 square. 2 square is equal to 4. You just follow this one. We have 4 elements in the power set. And suppose you have a set, say M, which is containing 5, 10, 15. There are how many elements are there? There are 3 elements. So what will be the cardinal number of the power set of M? The power set of M will contain 2 to the power 3, that is 8 elements. Okay, there will be 8 elements. This is the way to find the number of elements in a power set. If the set, so the last line, if a set has n elements, then the power set will have 2 to the power n elements. Okay, next is set operation. This is union. Union means the combining the 2 sets or more than 2 sets, and it is denoted by in this way: A union B. A and B are 2 sets, and A union B is also a set, new set, and which is containing the element X, such that X belongs to A or X belongs to B. X may be in the set A, X may be in the set B. So you take an example. The example is set A is containing 1, 2, 3 and set B is containing 3, 4, 5. Now when you want to combine them, that is to find A union B, you want to get A union B, then you have to combine the set, and in this set all the elements will be distinct. If you find any element is repeated, then take only one element out of them. Suppose in the set A there is 3, set B also 3, but you can write only one of them 3. So the union of this set is 1, 2, 3, 4. Okay, this is your A union B. So by notation also you can find, suppose this is the set A. Okay, this is the set A, another set is B, this is set B, and set A contains the elements 1, 2 and 3. Okay, and set B is containing the elements 3, 4, 5. This is 3, next is 4, next is 5. So if you want to get the combination altogether elements of A and B, that is A union B, then you will get this part. This is the blue part is the combined part of A and B, and A union B is getting the elements 1, 2, 3, 4 and 5. So this is the presentation of union. So another example, if you have 1, 2, this is a set, and 5 is another set, null set. So if you combine them, then you will get again 1 and 2, isn't it? Because 5 has no element, 5 is actually null set, it has no element. So you just union them, then you will get the another set, that is 1 and 2. Okay, next is set operation intersection. So set operation intersection is denoted by in this way: A and B are two sets. A intersection B is also another set, new set, and it contains the element X such that X belongs to A and X belongs to B. So here the conjunction is AND. In intersection you will get the conjunction AND, and in union you will find the conjunction as OR. Okay, in intersection this element X will be simultaneously belong to A and B. Okay, the same element X will be in set A and set B. Better you see the example. Set A is equal to 1, 2, 3 and set B is equal to 3, 4, 5. That means the element which is common to both the sets, that is 3 is the only element which is common in both the sets. So the intersection between them is the set which is containing the common element of A and B. Better you see the graph, Venn diagram. Say A and B, A contains the elements 1, 2, 3. This is 1, this one is 2, and this is 3. And B is another set which is containing 3, 4 and 5. Okay, if you intersect them, then you will find this part. It is actually the blue colored part is actually the common part. So this is your A intersection B. This is A intersection B. Okay, this A intersection B contains only the element 3. Thank you very much.